This video is about application of the first derivative. Guided practice 1. A company mines copper, where the mass of copper X is measured in several tons. The company's profit P, measured in millions of dollars, depends on the amount of copper mined. The profit is given by the function, this one. Find the P of 0 and P of 6 and interpret the results. So we have P of 0 equals, we plug in 0, 2.30 minus 0.05, 0 squared minus 12 equals negative 12. The unit is $1 million. Then P of 6 equals 2.36 minus 0.05, 6 squared minus 12. We put into calculator, you will get 0. The meaning for P of 0, when the company doesn't mine any copper, it will lose $12 million. When the company mines 6 tons copper, for P of 6, it will earn $0. Now for B, find the dP by dx. dP by dx equals 2.3x derivative minus 0.05 x squared to the derivative minus 12 to the derivative. So we have 2.3 minus drop down minus 1, you will get 0.1x. According to the definition, first the derivative is the instantaneous rate of change of a function at a point. Therefore, dP by dx is the rate of change of the profit with respect to the amount of copper mined. Let's say the meaning of the first derivative again. It represents the rate of change in profit with respect to the amount of copper mined. Now let's go to C. Find the value of P and dP by dx when x equals 20 and x equals 25. We will get the P of 20. Put 20 into the original function. We get the 2.3 times 20 minus 0.05 times 20 squared minus 12 equals 14. P of 25, you will get the 2.3 times 25 minus 0.05 times 25 squared minus 12 equals 14.25. So for P prime of 20, from B we already got dP by dx equals 2.3 minus 0.1x. So we plug in 2.3 minus 0.1 times 20 equals 0.3. For P prime of 25, you will get the 2.3 minus 0.1 times 25. That equals negative 0.2. Let's go to D. Interpret the answers to C. We have P of 20 equals 14, which means when the company mines 20 tons copper, the profit will be $14 million. P of 25 equals 14.25 means when the company mines 25 tons copper, the profit will be $14.25 million. For P prime of 20 equals 0.3, remember P prime means rate of change. So when the company mines 20 tons copper, rate of the profit is increasing at $0.3 million per ton of copper mined. Since this 0.3 is positive, that's why it's increasing. For P prime of 25 equals negative 0.2, when the company mines 25 tons copper, the rate of the profit is decreasing at $0.2 million per ton of copper mined. Now let's go to E. Find the value of x for which dp by dx equal to 0. So we will set up this equal to 0. Add 0.1x both sides. Then you divide it by 0.1 both sides. You will get the x equals 23. For f, determine p for this value of x and interpret this value. So you got the p23 equals. We plug into the original function, get a 14.45. When you interpret this value, we know we set up derivative equal to 0, which means we're looking for maximum or minimum. Definitely for this problem, we are looking for the maximum profit of the company is $14.45 million. Now let's go to guided practice 2. Haruka has an eco-friendly bag in the shape of a cuboid with a width 12 centimeters, length 36 centimeters, and height of 9 centimeters. The bag made from 5 rectangular pieces of cloth, and it's open at the top. Calculate the area of cloth in centimeters squared needed to make Haruka's bag. So the area of the cloth equals, look at the bottom, we have 12 times 36. On the front side, this one, that will be plus 36 times 9. We have front and back, so we multiply by 2. Then we check the side. This side, it will be 12 times 9. Also, we have this side, so we have multiply by 2. Then we put into calculator, you will get 1,296 centimeters squared. Let's go to 1b. Calculate the volume in centimeter cubed of the bag. We know for the volume, we have length times width times height. So we have 12 times 36 times 9 equals. So we get 3,888 centimeter cubed. Another girl decides to make her own eco-friendly bag in the shape of a cuboid, such as the surface area is minimized. The width of the bag is x centimeters. Its length is 3 times its width, and its height is y. So we get this is y, here is 3x, this is x. The volume of the bag is 3,888 centimeter cubed. Use this value to write down and simplify the equation in x and y for the volume of the bag. Volume, we use V stand for that. You will get the length times width times height. So we have x times 3x times y. So we get the 3x squared y. It equals 3888. It's given. Both sides we divide by 3. You will get the x squared y equals 1296. Now go to 1D. Write down and simplify an expression in x and y for the area of a cloth A used to make this girl's bag. So we have area equals the bottom part, we have x times 3x. For the side, you will get the x times y, then times 2. Then we have front. For the front area, it will be 3x times y. And also we have back, we multiply by 2. Simplify, we have 3x squared plus 2xy plus 6xy. So we have 3x squared plus 8xy. That will be A. Area of the back equals 3x squared plus 8xy. For 1E, use your answer to parts C and D to show that area equals 3x squared plus 10368 over x. Basically, we need to change this y into expression including x. From here, we divide by x squared both sides. You can get the y equals 1296 over x squared. Therefore, we plug in here. You will get 3x squared plus 8x times 1296 over x squared. Therefore, you will get the 3x squared plus 10368 over x. That's it. For 1F, find the dA by dx. So dA by dx, you will get 3x squared to the derivative plus 10368 times x to the negative first power, you do derivative. So we have 6x minus 10368 over x squared. Remember, for x to the negative first power, when we do derivative, you will get the -1 minus 1 x to the negative second power. Therefore, you get -1 over x squared. For 1G, use your answer to part F to show that the width of the bag is 12 centimeter. We want to get the minimum of area. Therefore, you will set up dA by dx equal to 0. So we have 6x minus 10368 over x squared equal to 0. We know that x cannot be 0. Therefore, for every term we multiply by x squared. We want to get rid of this denominator first. So we have 6x third power minus 10368 equal to 0. Adding this constant on both sides, you will get this. Then you divide it by 6 first. X third power equals 1728. Then we do the cubic root both sides. You will get the x equals 12. Look at the 1H. The cloth used to make the bag costs 4 Japanese yuan per centimeter square. Find the cost of cloth used to make the bag. From 1E, we know this is the area of the cloth. When x equals 12, we plug in. So we get the area of 12 equals 312 square plus 10368 over 12 equals. We got 1296 centimeters square. Then the cost equals this area 1296 times 4 equals. The answer will be 5184 Japanese yuan. Let's go to guided practice 3. A lobster trap is made in the shape of half of a cylinder. It's constructed from a steel frame with netting pulled tightly around it. The steel frame consists of a rectangular base, 2 semicircular ends, and 2 further support rods as shown in the following diagram here. The semicircular ends each have a radius r, and the support rods each have length L. Let T be the total length of steel used in the frame of the lobster trap. Write down the expressions for T in terms of R, L, and pi. From this diagram, we could see we have 4 this L. And the length from here to here, that's diameter. We have 2R. This will be 2R2. Then you calculate for this circumference, half of this circumference, multiply by 2, because we have another one here. In other words, these two adding, you will get the circumference of a circle. Therefore, for this T equals 4L plus 4R plus 2 pi R. Look at the 11b. The volume of a lobster trap is 0.75 meter cubed. Write down an equation for the volume of a lobster trap in terms of R, L, and pi. We know the volume equals 1/2 of a cylinder. And for the cylinder, I use VC stand for the volume of a cylinder. We know that it's pi r squared times the height. So we get the 1/2 pi r squared times height. Pi r squared, the height will be this L. Then we will set up this equals 0.75. For 11C, the volume of the lobster trap is 0.75 meter cubed. Show that T equals this. So we got the T equals 4L plus 4R plus 2 pi R. According to this, we can get L. How you get this L? In other words, how you isolate this L? We multiply by 2 both sides. Then you need to divide it by pi. Both sides. Then you divide it by r squared, both sides. So we get L equals 0.75 times 2, that's 1.5 pi r squared. Then we will substitute this L by using 1.5 over pi r squared. So we have 4 times 1.5 pi r squared plus 4r plus 2 pi r. So we get the 6 over pi r squared. According to the expression we are looking for, we need to factor this r. So we add r, take out 4 plus 2 pi. Then we organize into this format. We can write down 2 pi plus 4 r plus 6 over pi r squared. Let's go to 11D. The volume of a lobster trap is 0.75 centimeter cubed. Find the dt by dr. We know this t equals this. So we have dt by dr equals 2 pi plus 4 r. We have to do the derivative. Then plus 6 over pi r to the negative second power, we have to do derivative. For this one, that's a linear function, so we have 2 pi plus 4. Then plus, drop this negative down, we have negative 12 over pi r to the negative third power. We organize, you will get the 2 pi plus 4 minus 12 over pi r to the third power. Now go to 11E. The lobster trap is designed so that the length of steel used in his frame is a minimum. Show that the value of r for which t is a minimum is 0.719 meters. Correct to the 3 significant figures. In other words, we are looking for minimum. So we need to set dt by dr equal to 0. In other words, we need to set up this equal to 0 to solve for this r. So we have 2 pi plus 4 minus 12 over pi r third power equals 0. First of all, you will get rid of this pi r to the third power. So every term you multiply by pi r to the third power. Here's pi r to the third power. Pi r to the third power. So you will get the 2 pi square r to the third power plus 4 pi r to the third power minus 12 equal to 0. This is a power form equation, so I add a 12 for both sides. You will get the 2 pi square r to the third power plus 4 pi r to the third power equals 12. Then factor this r to the third power. You will have 2 pi square plus 4 pi r to the third power equals 12. Then you divide it by 2 pi square plus 4 pi, both sides. you will get the r to the third power equals r to the third power equals 0.371. Then you do the cubic root both sides. You will get the r equals 0.719. For the exam, you don't have to show the work like this. You just see we work through equation solver on the graphing calculator. So you will write down by equation solver in JDC. That's a graphing calculator. We got R equals 0.719. Let's go to 11F. The lobster trap is designed so that the length of the steel used in its frame is a minimum. Calculate the value of L for which T is a minimum. According to 11B, we have L equals 1.5 pi r squared. We already got from 11E r equals 0.719, so we plug in 1.5 over pi times 0.719 squared. You will get, answer will be 0.924 meters. For 11G, the lobster trap is designed so that the length of steel used in its frame is a minimum. Calculate the minimum value of T. We know T equals 2 pi plus 4 r plus 6 over pi r squared. We know this r equals 0.719, so we plug in 2 pi plus 4 times 0.719 plus 6 pi times 0.719 squared. You will get, answer will be 11.1 meters.